From the results and data collected, we can obtain the two main figures, which are the retention time and the peak area. Retention time is dependent on the polarity of the sample analyzed. The higher the affinity of the sample to the stationary phase, the higher the retention time. In this experiment, reverse phase liquid chromatography is used. Retention time is also dependent on boiling point. The lower the boiling point, the lower the retention time. The compound to be analyzed is caffeine. This compound, from the chromatogram, has a retention time of 3.040 minutes and was the last to elute. Thus, the compound has the best affinity to the non-polar stationary phase, which indicates that caffeine is the least polar when compared to other substances present.
The peak area is dependent on the concentration of the sample injected. This is based on a formula where concentration equals to peak area times detector response. The concentration is directly proportionate to the peak area. A higher concentration of caffeine will produce a larger peak area. Hence, from the chromatogram, it has a peak area of 1,147,539, which translates to 100 ppm in concentration.
We repeat the same process for the other concentrations to find out their retention time and peak area. A calibration curve can then be plotted with peak area against concentration. With the calibration curve, our samples, which is Coke and Pepsi, can then be analyzed by matching the peak area and concentration with the calibration curve. We can deduce the unknown concentration of caffeine found in the soft drink.